Here is the answer for the day 4 warm-up. Write a balanced chemical equation for each reaction by first writing the skeletal equation and then determining the coefficients. So the first thing you have to be able to do is change the words into the symbols for the different compounds and elements. So question A, sodium hydroxide, that's NaOH. You don't know that, then that means that you have to have a periodic table so you can find that sodium is Na. You also need to have the page 268 chart so that you can find out that the word hydroxide is OH. This is ionic, so when you write the formula, you have to balance the charges. You have to remember that sodium is a +1 ion because it's group 1. Hydroxide is a -1 ion on that page 268 chart. So having one of each of them gives you a balanced compound. All of that thinking happened when I was determining that I wanted to write NaOH. Okay. Now I'm going to write plus. I'm going to leave a little bit of space in case I need a coefficient number in front of the next thing. It says sulfuric acid. So now I need to remember how to write acids with the acid rules. Sulfuric acid is H2SO4. How did I get that? Well, I knew it had hydrogen, but I wasn't sure how many hydrogens. So then I looked at the name sulfuric, which ends in ic. That tells me that the original anion that's in the compound is a word ending in 8. So I needed a word kind of like sulfuric, but it ends in 8. I think sulfate. On page 268, sulfate is SO4, and sulfate has a -2 charge. So to have a +2 charge from my hydrogen, I need 2 of them. Okay, now here's the arrow symbol. Now after the arrow, I'm going to leave a little space in case I need a coefficient number. The next thing is sodium sulfate. That's Na2SO4. How did I know that? Sodium is a +1 ion, but sulfate is a -2 ion. To have these balance out, I need to have 2 of the sodium so that I have +2. Now I'm going to write plus. Again, I'm going to leave a little space in front of water. Here's water, H2O. That is the skeletal equation. Now I'm going to put in any coefficients that might be needed to balance it. There's 1 Na here, but the other side has 2 Nas. So how about a 2 in front? Writing a 2 in front of the NaOH also means that there are 2 O's. Also on the left side, there are 4 oxygens from the sulfate. 2 + 4 is 6. There are 6 O's on the left side. The right side doesn't have that many. It's got 4 here, but just 1 over here. How about we put a 2 there? That gets us our 6 O's. That makes 4 H's on the right side. On the left side, we also have 4 H's. Look careful. We have the 2 out front that distributes to that hydrogen. That's 2 hydrogens. And then right here, it just explicitly says 2 hydrogens. So there's the 4 hydrogens. The capital S also matches right now. There's 1 on both sides. So this equation was balanced by putting a couple of 2's in it. Okay, now question B. Nickel, that's Ni. Plus, now remember, leave a little space after the plus in case you need to put in a coefficient number later. Next is silver nitrate, AgNO3. Silver is a +1 charge, nitrate has a -1 charge. Again, use any charts that you might need to from your notebook to know those charges. Now the arrow. Okay, on the other side we have silver, so that's just Ag all by itself. Next comes nickel 2 nitrate. So NiNO3, and I actually want to have 2 of those NO3s. How did I know that? Okay, the name nickel 2 tells us that it's the kind of nickel with a +2 charge. Nitrate is NO3, and it has a -1 charge. Those don't balance, right? But a +2 would balance with a -2. So to have a -2, we need 2 nitrates. Next, let's do the coefficients. We got 1 nickel here, 1 nickel here. That's all set. We got one Ag here, one Ag here. That's all set. We have one nitrate here and two nitrates here. So we need to have a 2 in front of this. That gets us our 2 nitrates. But as soon as we do that, now we have 2 Ags. So we need a 2 in front of that Ag. Now everything matches.